Welcome to a hypothesis test example. So in this example, a study was run to determine if more than 30% of Bay Area community college students work full-time. A random sample of 200 students had 76 work full-time. Can we conclude that more than 30% of Bay Area community college students work full-time? So the very first thing we should do is simply understand the problem. So we were trying to determine if more than 30% work full-time. So we're not trying to estimate, we're trying to see if a fact is true or false. So that's sort of a key indication that we're doing a hypothesis test, not a confidence interval. We have a random sample, again, extremely important, which has 200 students. And 76 work full-time. So we have our random sample. Of n equals 200. And then our sample results. We had 76 work full-time. So our sample result, or our sample statistic, would be p hat is 76 out of our 200, or 0.38. And then we are trying to determine if the actual population proportion is higher than 30%. So if the true proportion is higher than 0.30. So this is sort of our base information. Next thing we want to do is to determine our hypotheses. So we're going to have two hypotheses. One is sort of what our hunch is, and the other is what we are going to use as our base assumption. So our hunch is that it's higher, more than 30%. We're going to use 30% as our base assumption. So we have what is called our null hypothesis. This is essentially our base assumption. And then we will have our alternative hypothesis. I'm going to give myself slightly more room. 1 moment. So we have our null hypothesis, and then we will have our alternative hypothesis. And this is essentially our hunch. So our null hypothesis often I write after our alternative hypothesis. So our alternative hypothesis is that more than 30% of Bay Area community college students work full-time. Our null hypothesis will be that exact same sentence with equality instead. So to create our null hypothesis, we're just going to switch to equality. So our null hypothesis will simply be that 30% of Bay Area community college students work full-time. Now we can also use notation instead of writing out the words. So using notation, the null hypothesis we can denote with a h sub 0 for our null hypothesis. Our alternative hypothesis we denote with an h sub a. And then we are talking about proportion. Our null hypothesis is that that proportion is equal to 0.30. Our alternative hypothesis is that that proportion is greater than 0.30. Again, remember for the less than or greater than symbols, the small point goes towards what we're assuming is the smaller number, and the wide open mouth goes towards whatever we assume is the larger number. So if we're assuming the proportion is larger than 0.30, then the wide mouth should be next to the p. All right, so these are our hypotheses. From here, we have to justify running the hypothesis test. This is the same idea as with the confidence intervals, but in this case, we do actually know p, or at least we have an assumed p. So first up, do we have a good sampling technique? It's random, and it draws from the entire population. So we meet the criteria for a good sampling technique. Then the normality of the sampling distribution, we need to check that n times p and n times 1 minus p are both 10 or more. So remember in this problem, our n is 200. P is the assumed proportion from our null hypothesis. So our P will be 0.30. Again, this is the assumed proportion from the null hypothesis. So from here, we have n times p is 200 times 0.30, otherwise known as 60. N times 1 minus p is 200 times 1 minus 0.30, otherwise known as 140. And these are both definitely 10 or more. And so we can go ahead and run the hypothesis test because we have a good sampling technique and our p-hat distribution, we meet the conditions for the p-hat distribution being normal. So we can run the hypothesis test. Because the sampling technique was good. And we meet the conditions for normality of the p-hat distribution. From here, we need to study our p-hat distribution. We already did normal as we saw in step 3. Our center, mu sub p-hat, should be equal to p. So mu sub p-hat is our assumed 0.30. And our sigma sub p-hat is the square root of p times 1 minus p divided by n, or the square root of 0.30 times 1 minus 0.30 divided by 200. If we do those calculations, we wind up getting 0.0324, more or less. From here, we want to see how our sample fits in the distribution and then determine if it's a surprising sample. So we take our p-hat distribution, which we know to be normal. Its center is at 0.30. Our sample is at 0.38. So our sample is over here. And then we want to look at the probability of being more extreme. From here, we're going to convert this to z-score. I have the same picture, but with z instead. So we will do z is equal to essentially our sample minus the mean divided by the standard deviation. Our sample, we had 0.38. We'll minus off 0.30 and then divide by that 0.0324 we found earlier. So if we do that, we wind up getting 2.47 approximately. So this is our z-score. So this new z-score is at 2.47. I'm going to give myself a little more room. From here, then we need to calculate using our normal distribution calculator, which is in Canvas. So I'm going to pause and switch over to that screen. So our normal distribution calculator is at the end of the modules. And if we go to the normal distribution calculator, we can now add in our z-score of 2.47. And we are looking to the right of that z-score. So we have a right area of 0.0068. I am just going to record that on my tablet. So we have a right area of 0.0068. And now I'm going to switch back. So again, this was using that normal distribution calculator on Canvas. We had a right area of 0.0068. So this is the probability of getting a sample. As extreme as ours. If 30% work full-time. So if 30% of Bay Area community college students work full-time. So that's a very tiny probability. That is definitely a surprising result. So again, it's surprising if the original assumption is correct, which makes us consider the fact that maybe that original assumption is wrong. So our conclusion, our sample essentially is strong evidence that more than 30% of Bay Area community college students work full-time. Now, it's not guaranteed, right? It's possible if it is actually 30%. We do have a 0.0068 probability of getting such a sample, or one more extreme. So that's about a 0.68% chance of picking such a sample, even if it is actually 30% that work full-time. So we haven't proven that it is more than 30%, but we at least have strong evidence towards that. So this is hypothesis testing. We will do more of this in future modules.